So we are finally done with the expression. It is merely middle school level calculations. So what we do? We just have divide away on this, we will club the terms. This LON minus 1, LON minus 1, this is minus T. So OA minus T into LON minus 1 plus T, and this we can go take on the other side. So it is very simple. I think we can skip the step. LON, that is what we want, is equal to OA minus T upon OA LON minus 1 OA LON minus 1 minus T LON minus 1 plus T. So OA minus T, this OA comes on this side, plus T is here upon OA. So ultimately the final expression is, which is quite simple, and then we can analyze and we can just verify how it will work. So I write the final answer as LON is equal to OA minus T upon OA, that I will call as C1 LON minus 1, that I will call as CO into LON minus 1 plus C2. So this is a difference equation. So this is a different, or rather this is the solution in terms of a difference equation, where the this is what we want. What we wanted to find out LON, that is the rate at which water is going to increase. We want to find out, or increase, I should not use the word, we want to find it out. LON, that is, the question is find output water, how it increases, is some constant into previous level plus some other constant C2 plus some other constant C2 plus some other constant C2. So it is quite obvious and simple answer. LON is equal to C1 minus C1 LON minus 1 plus C2, where C1, what is C1? Where C1 is equal to OA minus T upon OA, and C2 is equal to T upon OA, where O is opposition, A is area of the tank, and capital T is the sampling interval between two readings. So if we decide that O, let us say for time being, if we decide OA as 100 and capital T as 1, if we decide OA as 100, capital T as 1, then C1 will be 0.99 and C2 will be 0.01. C1 will be 0.99 and C2 will be 0.01. So what is LON? LON is equal to 0.99 times previous level plus 0.01. This is something which is quite interesting, and rather using this simple, it is now high school level equation. equation. You can start with LO0 is 0, LO minus 1, LO minus 2 have no meaning, they are always 0 because we start counting from 0. So simply if we start, what is LO1? That is when we open the stopper. What we are doing? We open the stopper and start a stopwatch. You can have the system of actual tank, you can have mobile, and you take snaps at every second, or you take, because capacity is 1, you take snaps at every second. These will be your LO0, LO1, LO2, LO3 and so on. So what is LO1? LO1 is 0.99 LO0 plus 0.01. What is LO0? LO0 is 0. So LO1 is equal to 0.01. LO1 is 0.01. What is LO2? LO2 is 0.99 into LO1, that is 0.01 plus 0.01. So that is equal to 0.01 plus, that is 0.0099 plus 0.01, that is 0.0199 LO2. What is LO3? LO3 is equal to 0.99 into 0.199 plus 0.01. So like that, now you have learnt C programming. In C, you write a simple program to compute LO, N, and you can have the levels LO0, LO1, LO2, LO3, LO100, LO1000, like that. You can have the levels, and you will find that between LO0 to LO0 was 0. So between LO0 to LO1, it increased by 0.01. Between LO1 to LO2, it increased by 0.0099. Here you will find that it will increase by somewhat less. So you will find that in every reading, water level in the right hand side tank is increasing, but the increase is decreasing. प्रत्येक पुढच्या टाइम इंटरवलला उजव्या टँक मधल्या पाण्याच्या पातळीमध्ये वाढ होते, परंतु ही वाढ प्रत्येक रीडिंग नंतर कमी होत जाते. This is called as asymptotical rise. Listen very carefully. The water in the right hand side tank is continuously increasing, but the rate of increase is continuously decreasing. Is it clear? The water level, after each reading we will see that the water level in the right hand side, every LON plus 1 is greater than LON, but the difference between these two levels is continuously reducing. Water is rising, but the rate of rise is decreasing. Water level increases, but the rate of increase decreases. This is the simple way, common sense also. As water level increases, what will happen? This water level increase will decrease. It is just like Lenz's law. What is Lenz's law? In electromagnetics you have seen that in Lenz's law the EMF acts in such a manner so as to oppose the cause producing it, and thus the system is in equilibrium. So what is the cause for water level to rise? This flow. And as this flow is there, water level rises. What is the cause for this flow? Difference between this level and this level. What is this level? This level is constant. So the level difference between level difference in two sides of the wall is the cause for flow. The flow results into increase of water level rise in the right hand side tank. So the effect of flow is, why flow is there? Because the level difference. What is the effect of flow? Effect of flow is to increase this level. When this level increases, the level difference reduces, flow reduces, but flow is always there. So because of this, if you plot the readings, you will get an answer like this. Just like a staircase with the step size reducing. This is called as asymptotical. Staircase like with the step size of the staircase reducing. So you can have, if you want to plot it, how to plot this, there is a technique. It is staircase. Because in between the lines you don't take. And these are not important too. So it is a staircase like this. N and LON. And how we plot it? We plot it with asymptotical like this, and by plotting staircase with the step rise decreasing. Width of the staircase is same, height continuously decreases. So it is in this manner. It is in this manner. Is it right? So LON is equal to C1 LON minus 1 plus C2. LON is equal to C1 LON minus 1 plus C2. Now this is called as difference equation. Very easy. It doesn't require any complex mathematical calculations, especially calculus, derivative and integration, which something is not so easy. I mean, it's not difficult or impossible, but only thing is that you have to apply some mind. So you may be aware that few years back, Government of Maharashtra has introduced the concept of algebra geometry and simpler mathematics. बीजगणित भूमिती आणि त्याला पर्याय म्हणून सामान्य गणित. So like that, I actually think that this calculus is something, means teaching complex things when the mind is not ready is actually a brutality. So we should not go for that. This everybody understands. This everybody understands. Now, in fact, we define what is derivative. What is derivative? So, if LO is the variable, LOT is the variable, then LOT is the variable. So, derivative is what? Derivative is dLO, we can write T, or it is assumed that practically everywhere, dLOT by dt, I write on this side. What is first principle of derivative? dy by dx, or we can have dy by dx, okay, it's alright, or dt, it's better dt, it is better, dy by dt is equal to f of x is equal to f dash x is equal to f of x plus f of x. F of x, I think you must be remembering this. F dash x is equal to f of x plus h minus f of x upon h as, and this as limit f dash x is equal to limit as h tends to 0 f of x plus h minus fx upon h. This we also called as dx by dh, or in general what we can have dy by dt, or we can say dx by dt is, why we use time, is equal to limit as t tends to 0 f of x plus t minus f of x upon t. In this, I want to make a small change. I don't much agree with this. Then you say, what nonsense you are talking about? It's a universal expression. Then keep it in mind that your conviction should be so strong that you should tell the entire universe that you should be able to tell that the universe is wrong. So even though it's universal, it doesn't mean that it has to be true. I want to make a small change because this is something in future as it is real time. So this is I don't want. Something in future I should not define. So can I correct it like this? dx by dt is equal to limit as t tends to 0 f of x minus f of x minus t upon. I hope it is quite clear now. I think now there is no need of this tan to remain so that we can use the space. We are just coming at the final expression now. So this is the derivative expression. dx by dt is equal to limit as f of x minus f of x minus t as capital T tends to 0. So I can write similarly, I am using dLO. Is actually x bracket t is there, but we may or we may not use it. Is assumed that everything is function of time. dLOt by dt is equal to LO now here something what has happened is value of function, to be very precise we should not write it, we can say there is no need, we can make it instead there is no need of x again, so we can have f dash t like this, where f dash t is assumed as this, we can have again like this, it is better description. So f dash t, time derivative of a given function, time derivative of a, so this is just what I have done, x I will place as t and t as delta t, it is one and the same. So I again re-explain, time derivative of a function is value of the function at given time minus value of the function at previous instant upon the instant due in previous time slot upon time slot as time slot tends to 0. So dLOt by dt is LOT minus LO T minus delta T upon delta T as this as limit delta T tends to 0. Limit as delta T tends to 0. Here what we are having in this expression, so now you can interrelate these two expressions very nicely. You can interrelate these two expressions very nicely. So what is L? This I can write as dLOT upon dt is equal to limit as delta t tends to 0. LOT I will replace as LON minus this I will replace as LO n minus 1 and this as T, because if I use current instant, so if T is equal to NT, so T is NT, T is NT minus T minus delta T, T minus delta T is previous instant, it is previous instant and capital T. So LOT is current sample, LOT is LON, that is current sample, LOT minus delta T is previous sample, and it is the intersampling time, it is intersampling time, and as it tends to 0, as it tends to 0, this is derivative. So we can write dLOT upon dt is equal to LON minus LON minus 1 upon capital time. If this capital time is, this we can write, if this capital time is too small, if capital time is tending to 0. Now, or if you want, you can have limit also on this side, dLOT by dt is equal to limit as capital T tends to 0. Now multiplying both sides, now we can remove limit if the denominator we get rid of. So multiplying both sides by capital T, we get T dLOT upon dt is equal to LON minus LON minus 1. LON minus LON minus 1. And now there is no need to put limit, because this we have get rid of. This we have get rid of, and this T should be, this is true if this T is very small. T tends to 0. And then from this equation you can construct, you can have this term and you can construct the difference from difference equation. You can construct from difference equation you can construct differential equation. So I end today's session with a very heavy task assigned to you. From this difference equation, using this terminology of first principle of derivative, try to construct the final answer. It's very big task. From this, try to derive an expression for LOT finally. Try to derive an expression for LOT finally, that is, you will get from difference equation, as the interval becomes smaller, you will end up with a differential equation, and I want you to develop it before we meet tomorrow. I think it's too much heavy dose today. We end now.